Welcome to the Pixl Club Practice Paper 1 Edexcel linear paper for the higher tier in June 2013. This is the formula sheet of the paper. Now, it may or may not come in handy for some of the questions, but it's always worthwhile knowing what's in there. The volume of the prism and the area of the trapezium. Now, they're usually on the only things on the foundation paper, but you get a few more things on the higher paper. You can see we've got the volume and surface area of a sphere, the volume and surface area of the cone, or curved surface area, which is different to the whole surface area, the total surface area. And then we've also got the advanced trigonometry rules, the sine rule, the cosine rule, area of a triangle, and of course the quadratic equation, which is down the bottom right hand corner. If at any point in any exam you need to use these formulae, just look at the front page, look at the formula sheet, and just copy down directly the formula as it stands into the place where you are trying to use them. If you don't, you may well enter the values you're using incorrectly, and then you'll get the wrong answer, and it's just a shame to lose marks for that. Okay, let's begin. Okay, so we're going to start off with a stem and leaf diagram. Now, it is important to look at a question like this and realise there is a space and there is a grid for the stem and leaf diagram. The space is to be used to put the numbers in order. Now, the easiest way of doing this is doing an unordered stem and leaf diagram and then putting the numbers into order. So we're just going to make this a little bit bigger, and we're going to create our stem and leaf diagram. So using red pen, we are going to create a stem and leaf diagram starting off with 10, 20, 30 and 40. We don't need to go any higher than that because there are no more numbers higher than the 41. So to put the numbers into the stem and leaf table, first of all we have 11 right at the top, so we're going to put that one there with a 1. So that means 10 and 1, 11. And we're going to go on to 36, 3, 6, 36, 23, 28. It's always helpful just to put a line through the numbers so we know that we've used those and we don't double up on them. 36, 40, 31, 13, 26, and so on. Now you might notice I'm trying to do this nice and tidily so the numbers are in line with each other. It is important to keep a stem and leaf diagram nice and tidy. You will lose marks if this is not done. Okay, so now this is done, what we need to do is transfer this information onto a stem and leaf diagram in order. Okay, now you noticed I put in my stem 10, 20, 30 and 40. Well, you can just do 1, 2, 3, 4 as long as you allow for this in the key. So we're going to do 1, 2, 3, 4, and then of course we have the numbers 1, 3, 8 and 9. That's in order in the 10. So 1, 3, 8 and 9. Okay, in the 20s we have 2, 3, 5, 6 and 8, 1, 6, 6, 6, 0, 1. Okay, so that's obviously stem and leaf diagram complete, but as my mum used to say to me when I was a kid, don't leave home without your keys, don't forget your keys. We can do that. We can just take the maybe the 31 from the third row down, and we just say 3 line 1 equals 31. Now this does refer to number of flower buds on plants, so we could put in the key 31 buds. That question's done. That's the 3 marks. Next thing we need to do is write down the mode. Well, we know that the mode is the most common value. So we just look at our stem and leaf diagram. We should be able to see clearly that the most common value is 36 because there are 3 6s there. Okay, so 36 would be our mode there. 36 buds again, if you like. You won't lose the marks if you don't write buds there, but it's being complete. That's that question done. Nice start to the paper. Okay, so moving on to question 2. Question 2 is a straightforward long multiplication question. Now there's several methods for doing this, and it's important that we recognise that All methods are fine as long as they work and they're accurate. Okay, so I'm going to be working with the grid method because it's one of the most commonly taught in schools. That's going to be 400. What we're doing here is we're breaking the 423 up into 3 columns, and the 12 turns into 10 and 2. So we need to now do a multiplication. 10 times 400 will be 4,000. 10 times 20 would be 200. 10 times 3 would be 30. 2 times 400 is 800. 2 times 20 is 40. 2 times 3 is 6. Now we need to add these numbers together, all 6 numbers. Now that might be worthwhile just thinking about the 2 numbers above each other. So we start off with 4,800. That's quite a nice, easy one to add together, 4,800. Then we've got 240. That's obviously the 200 and the 40 added together, and the last one is 36. Doing it this way means we're not trying to add together lots of different numbers all in one go. So if we now just add those together, that's going to be 6 in this column, 7 in this column, 10. So what we do is put the 0 there and carry the 1, and 4 plus 1 is 5. So the answer is 5,076. So I'm going to come over here, 5, 0, 7, 6. That's it, that's your 3 marks. Now you just need to be careful with these questions. It's quite common for long multiplication to go wrong because people aren't careful, they don't think about the techniques, but bear in mind you do long multiplication all the way from year 6, if not year 5. So you should know how to do it, you just need to make sure you do it carefully. Okay, question 3. Here we have a forming and solving equations question all about quadrilaterals. So we're just going to look at these first of all. We've got these angles in here. Now they don't have numbers apart from one of them, the rest they're all algebraic, so what we need to do is just think about adding those together. We know that when we find the sum of angles in various shapes, we know the total. For example, a triangle adds up to 180. This is a quadrilateral, as it states. A quadrilateral adds up to 360, so we're just going to write in 360, and of course that is going to equal all the angles added together. So 2x plus 2x, and move along a bit, plus x plus 10, and then last of all add 50. Okay, so they're the 4 angles. Now all we need to do is just simplify that. Okay, so we have 2x, 2x and x, so that is going to equal 5x. We'll put 5x down there, and then we had the 10 and the 50, so that's going to equal 60. Okay, they still equal 360. So that's our equation in x for the angles in the quadrilateral. That's what they're looking for. Okay. The next thing they're asking us to do is work out the value of x. Okay. Well, that basically means solve the equation. Okay, nice and simple. 360 equals 5x plus 60. So if we solve this equation, we need to start thinking about getting the x on its own. We need to get the x on one side and numbers on the other. To get rid of that x, we need to first of all take away this 60. We do the inverse. The inverse is add 60 is take away 60. If we do it to one side, we must do it to the other side for it to remain balanced. If we take away 60 from both sides, that leaves 300 on this side. This will equal 5x on this side, because the 5x is not touched. It's not affected by the 60, but the 60 take away 60, well, that's gone, that becomes 0. Now we've got the calculation 300, or the equation 300 equals 5x. Okay, so we still need to get rid of something. We need to get rid of this 5. Well, 5 times x is the same as x times 5. The inverse of x times 5 is x divided by 5. So if we have a times by 5 and divide by 5, they will cancel each other out. But we must do the same on the other side. We need to divide by 5 over here. So x is going to equal 300 divided by 5, which equals 60. Okay, and that's the value of x. That's our answer that we want. Okay, so obviously I haven't filled all of this in. That needs to go in there, and that needs to go in there. Those are our answers. Okay, so here we have a recipes question. The recipe is obviously for 6 people, It's a melon sorbet for 6 people, and Terry wants to make the sorbet for 18 people. So we need to work out what the mapping is to go from 6 to 18. What calculation do we do to go from 6 to 18? Well, this is fairly simple. It's just times by 3. So we would do this with all the ingredients as well. Now, because we start off with 100 grams of caster sugar, we multiply that by 3, and we get 300 grams of caster sugar. 300 grams. Okay, moving on. Headley makes melon sorbet as well. He uses 2 limes. How many people is he making the melon sorbet for? Well, we can look at the original recipe for 6 people, and we've got half a lime. So we're going to write down half a lime, and that's going to be scaled up, or it's going to be mapped to 2 limes. So what calculation is that? Well, you need 4 lots of half a lime to get 2 limes, so we're multiplying by 4. So we know that from the recipe is for 6 people. We're going to multiply 6 by that scaled up amount, that 4, and that's going to be 24 people. Okay, 24. Right, now moving on to a scatter diagram question. Scatter diagram question is talking about the height and length of sheep, and the first thing we've been asked to do is plot 2 points on the scatter diagram. The first sheep is 65 centimeters high and 100 centimeters long. So to start to the scatter diagram here, 65 centimeters and 100 centimeters is going to be about there. Now that's slightly off because of the pen used to plot this, but that's basically about where it's supposed to be. You will be allowed some margin of error, but not a lot. The next one's 80, height and length 110. So 80, 110 is going to be there. Okay, again slightly off, but it's good enough. Right. So those are the 2 points. That's our 1 mark for that. Now we need to describe the relationship between the height and length of the sheep. Well, basically when we talk about relationships on scatter diagrams, we could discuss about how the height increases, so does the length, or we could say one value increases, another value decreases on a different type of scatter diagram, but ultimately we can see it's going uphill, and so we're going to talk about correlation. And the correlation here is positive correlation, so we write positive correlation. And that just means there's a relationship. As one value increases, so does the other. Now the last part of this question is the height of a sheep is 76 centimeters. Estimate the length. Well, we use the scatter diagram to do this, but it's really important we do one thing before we try and do the prediction. We've got to draw in the line of best fit. So many people forget to do that. So the line of best fit is just a line that goes through as many of the points as possible. It doesn't have to go through any particular points. It doesn't have to have a particular number of points above or below the line, and it certainly doesn't have to go through the origin, but we need to have a straight line, and this is quite difficult with this machine. We're going to have a straight line going through the points like that, preferably done with a ruler, and then what we need to do is find our value that we're checking out. So the height of the sheep is 76 centimeters, so what we need to do is a line straight up at 76 on the graph. So 76 is here, go straight up. At that point we need to cross from there all the way across to the other axis. Now that isn't particularly straight line, again it should be done with a ruler, and that would give us 106 to 108, probably more like 108. So we're going to write an answer of 108. This is going to vary slightly between papers. It does depend on how accurate the line of best fit is and how well it's read off, but there will be an allowance for slightly different answers. Okay, this question here is going to be quite tricky to do because it does involve using a pair of compasses which I cannot use on this tablet, but what we can do is talk about how to do it. So first of all we need to set our compass to a certain size. Now if you notice it says that the shopping centre will be built less than 12 kilometres from Middleton. Right, well 12 kilometres on this scale is going to equal 6 centimetres. Okay, 6 centimetres from Middleton is about here. No. Okay, so what we need to do is set the compass point on Middleton and set the compass to 6 centimetres long, and we're going to draw a curve from about here, and it's going to be, I need to turn the pen on, there you go, from about there, and there's your curve. Now I apologise, this isn't the greatest curve, I've done it without a compass because of the software as I mentioned, but that is supposed to be done with a compass with the centre at Middleton. Now from Newtown it mentions it's 15 kilometres, so we need to work out the scale that we're going to use. 15 kilometres, well, if it's 1 centimetre to 2 kilometres, that means we are going to do a line 7.5 centimetres long. Okay, so again, centre of the compass at Newtown, and it's going to be 7.5 centimetres, it's going to take up to about there, and then it's going to be a curve from there. Okay, again, the line's not particularly accurate, but the point is there. We have two curves, and where they cross, now we're looking for the area where the shopping centre can be built. Well, less than 12 kilometres from Middleton is this direction from there, and less than 15 kilometres from Newtown is there. So it's going to be this section in the middle. Okay, and that's actually the question complete. Okay, question 7 is all about the cost of buying gas from different companies. We're going to look at 3 different companies, and you can see down in the table below the graph there is 3 different companies: North Eastern, Pacific and East Anglian. We're going to work out how much it costs to use 100 units and how much it costs to use 200 units for each company. I'm going to start off with North Eastern. Okay, so North Eastern. Well, North Eastern basically have a basic cost of £30, but there's nothing added on, because if you look at the actual table here, it says first 200 units free. So whether you use 100 units, 200 units, it's all free. It would cost more money after that. So North Eastern straight away is just £30. Okay, Pacific is a bit more complicated because it's 20p every unit. So we're going to move on to the next page. Okay, so we're going to start off looking at the Pacific company. So Pacific, make sure we're clear about which company we're looking at. Right, so Pacific is 20p times the number of units, 20p multiplied by 100 units, which equals 2,000 pence or £20. Okay, £20. And then 20p multiplied by 200 units, which is the other extreme, and that's going to be 4,000 pence, which equals £40. Okay, so that's Pacific done. So we're going to move on to East Anglian. Okay. Ooh. And now we're looking at a startup cost of £10. Okay, plus 10p per unit. So we're going to multiply that by 100. And that will equal 10 plus, well, 10p times 1,000 is £10. It's 1,000 pence and £10. So that's going to be £10 plus £10, which is £20. That's for 100 units. And if we do that for 200 units, so that's going to be £10 plus 10p times 200, which is 2,000. 10p times 200 is 2,000, but that's £20, so that's £10 plus £20, which equals £30. So it gives us our two extremes. Okay, so we can now look at the between £20 and £30 for East Anglian. We can look at the between £20 and £40 for Pacific, or if we go back to the initial company, which was North Eastern, it would be a basic cost of £30, whatever. Okay, so first of all, if you use Pacific, it's going to go up to £40, which is more than the other company. It's more than £30. So Pacific will be more than North Eastern for the higher amount. Okay. So at this point, the North Eastern company is cheaper. So if we compare the North Eastern North Eastern are £30 standing, but East Anglian will be less than £30 for anything under 200 units. So East Anglian will be less than North Eastern for anything other than the full 200 units. Therefore, East Anglian are the cheapest company for Erica. Okay, so here we have some angles and polygons. We need to start looking at the internal angles or the interior angles of polygons. We've got two different shapes here. We've got the six-sided hexagon, so 6 sides there, and we've got the 8-sided octagon. Alright, so how do we find out what the internal angles are? I mean, obviously we're looking for X, which isn't part of the shape, but we will use the angles, and I'll show you later how we can find this out. So first of all, we're going to zoom in a little bit onto the hexagon. Okay, so we're going to split this hexagon into 4 triangles. Okay, those 4 triangles each have 180 degrees in them, as in the 3 corners of each triangle add up to 180. So if we've got 1, 2, 3, 4 triangles, we have 4 times 180, which is 720 degrees. Now that amount is the total internal angles of a hexagon. If we want to know one angle of a regular hexagon, we just divide this by the number of corners there are, number of vertices. So divide by 6, and that equals 120 degrees. So each angle, 1, 2, 3, 4, 5, 6, all have an angle of 120 degrees. 120 degrees. Okay, we use the same process on the octagon. So this is the octagon here. Let's make it a little bit smaller. Okay, and we're going to split it into triangles. Now we just go from one point again, and that gives us 1, 2, 3, 4, 5, 6 triangles. Okay, which means that if we just move that across a little bit, we've got 6 times 180, which equals 1080. And then to find out what one of those corners would be, we do 1080 divided by the number of corners, which is 8, and that would give us 135. So just move that over and write in 135. So let's take a bigger view of the picture. Okay, we've got here 2 polygons, and we're going to zoom in onto the X, the area we're trying to find. Now I'm going to go right in to avoid any confusion from anything else. Okay, so we've got the 120 degrees on that, on the left, the upper left, and here we've got 135, which we just calculated. Okay, so 120, 135, and the X all make round a point kind of angle. Okay, so round of a point, the angles add up to 360. So what we're going to do is going to add together 120 and 135. That's going to equal 255. We're going to take that number away from 360 because they add up to 360. 255, and that's going to give us 105 degrees, and that's going to be the value of our X. So we can write that into our answer. Is there an answer box? Well, we can write down at the bottom X equals 105 degrees. Now, it's always worth checking to see if that makes sense. Let's have a quick look at the angle itself. Well, the angle there is clearly bigger than a right angle. A right angle is 90 degrees, so just bigger than 90 degrees is fine. 105 degrees. Okay, next question. Okay, so here we have 3 different shops selling trainers, and we need to work out how much each trainer costs. It's asking us to see where the best deal comes from, but we can't just write down the name of the shop. We need to show some working as well. Alright, let's start off with the left hand side, the Sports for All trainers. Okay, it's starting off with £5, plus 12 payments of £4.50. So let's work out what 12 times £4.50 is, and that's going to be £54. Okay, then we need to add on the initial £5, so 54 add 5, that's going to be £59 in total. Okay, next we're going to look at Edexcel sports trainers. Edexcel sports trainers, 1/5 off £70. So we need to work out what 1/5 of £70 is. Well, this is going to be a different question, so we need to separate them up. 1/5 of £70, we'll divide 70 by 5, and we're going to get 14. Right, so that means the price that the trains have been reduced by is 14. So if we take the initial price of 70 and take 14 away, that's going to give us the price £56. I'll put the pound sign there. I didn't really have space over here. This one was cost 59. I'll write that again. Right, moving on to the last one. Keith sports trainers, £50 plus VAT at 20%. So we need to work out 20% of £50. 20% of 50. Well, 10% of 50 is going to be 5. And 10% equals £5. 20% is just double that, which is going to be £10. Okay, so £50 plus the VAT of £10 is going to be £60. Okay, so the question does say which shop would Samantha buy trainers to get the best deal, so we need to say, let's just zoom in a little bit and make a bit more space. We need to say, well, the cheapest here is clearly going to be the £56 in the middle. So £56 in the middle comes from Edexcel sports trainers. The cheapest deal comes from Edexcel sports trainers. Nothing wrong with referring to the actual amount as well. Let's put in brackets £56. Okay, that's 5 marks. Bearing in mind you get marks for all the work in there, not just for the statement at the end. Okay, next question is about algebra. Just nice expanding brackets, so let's just zoom in on the brackets to make it a little bit easier. Okay, we're going to start off with x multiplied by x. With multiplying out brackets is the same as expanding brackets. X multiplied by x is x squared. X multiplied by 5 is 5x. Negative 3 times x is going to be negative 3x. Now I mentioned a negative, that's because the other two are positive, so I should probably write a positive sign in there. Negative 3 times 5 is negative 15. Okay, that's not finished, that's expanding, but it's not the simplifying. So if we simplify that, we get x squared, because there's no other x squared terms, then we get plus 2x, take away 15. That's going to be our answer. There we go, 15. Moving on, we've got a solving equations question. Solving equations means finding out the value of x. So the problem here is we've got a 4 on the bottom of a fraction. Now they're always awkward to have numbers on the bottom fraction, so we get rid of them first. Okay, if we're dividing everything on the left hand side by 4 at the moment, the opposite of that would be to times by 4. Now all this does on the left hand side is cancel out. Divide by 4, times by 4. Remember, of course, if we are going to divide or multiply by 4 on one side, we must multiply the other side by 4. Solving equations is always about doing the same thing to both sides. But if we multiply the right hand side by 4, we need to multiply all the right hand side by 4. So x plus 5 in brackets. If we do x times by 4, we get 4x. If we do 5 times by 4, we get 20, positive 20 of course. That equals 29 take away x, which is just what was on the top of the fraction before, the numerator of the fraction. Okay, now we have something a bit more familiar with. We need to make sure all the x has gone to one side. The lower value of x is over here, so we're going to deal with that first of all. We're going to add that, because it's negative at the moment, add 1x. We're going to add 1x over here as well. Okay, so the 29 is untouched. That equals 5x, because 4x plus 1x is 5x, and then 20 is untouched as well. Next stage, we need to get rid of the 20 because we want to get the 5x on its own. Take away 20, and we do the same to the other side. That leaves us with 9 equals 5x. Okay, last thing we need to do is get rid of the 5. Now at the moment it's x times by 5, so we divide by 5 and they cancel. Divide by 5 on the other side, and that gives us our answer, 9 over 5. Let's write that one more time. X equals 9 over 5. That's done. So this question is about rotation. Now the problem with rotation is that we need tracing paper really to do it in the most easiest way. And what we would do if we had tracing paper is we'd trace the shape, and we'd also make a point that we're looking at the centre of rotation at 0, 0. We'd then put our pen over that point and turn the tracing paper, rotate the tracing paper at 90 degrees clockwise. Now that's going to bring one of the corners down here, another corner there, another corner there, and all the tracing paper will do is just show us where it's going to be. So we still need to draw in the shape. This is where the shape's going to go. Okay, that's it, 2 marks. If you are unsure if you've done it enough, then you can just do a little line between corresponding points and the centre of rotation, and then you should just see that's a 90-degree angle. That means it's rotated 90 degrees. That's it. Okay, so this question is asking us to describe the single transformation to go from shape P to Q. Now there are 4 different transformations that you could use. You could use reflection, rotation, translation and enlargement. Well, it's clear that P has been made bigger to become Q, so this must be enlargement. So that's going to be the first part of our answer. Enlargement. When we are describing transformations, we need to include some key bits of information. Now when we're talking about enlargement, there's 2 things we need to look at. It's the scale factor and the centre of enlargement. Centre. Okay, so the scale factor is first of all how much has been enlarged by. Well, if we look at the size of this shape, we can see that the P is 3 squares high, and we can see that Q is 9 squares high. Well, that means the sides of P have been multiplied by 3. So the scale factor is 3. The next thing we need to do when describing enlargement is talk about the centre enlargement, which just states exactly where the enlargement is going to happen. So we actually need to draw lines going from corresponding points. Now the easiest one is this one here, and that's going to go through there. Okay, then we're going to go to the top corner, and that's going to come through that point and that point. And we can start seeing where that centre is going to be, because it's where those lines meet up. Keep going. And with a ruler you can be a lot more accurate with this, but we can see straight away now that the centre enlargement is going to be at 0, 1, along the corridor 1, along the corridor 0, up the stairs 1. So that's going to be 0, 1. And that's your full marks for that question. Okay, so this question is about equation of straight lines, but it's also about plotting straight lines. Now if we ignore the question that's already there, or the line that's already there, and we're just trying to plot the line y equals x over 2 minus 1, well, whenever we plot lines we can always do xy coordinate grid, coordinate table, sorry. So if we start off with x equals 0 along the corridor 0, if we put that into this equation here, we're going to get y equals 0 over 2, which is 0, take away 1. So that's going to be negative 1. If we then put 1 into that, we're just picking up 0, 1, 2, because they are the easiest numbers to work with, but we'll keep going until we get to about 7. We're going to have 1 over 2, which is half, and then we're going to take away 1, which is negative a half. We're going to have 2, and that's going to give us 2 over 2, which is 1, take away 1, which is 0. Then we're going to have 3, make that a little bit bigger so we can fit it in there. And then 3 over 2 is the same as 1.5, take away 1, which is a half. And if we keep going with 4, 4 over 2 is 2, take away 1 is 1. 5 over 2 is 2.5, take away 1, which is 1.5. Okay, and then 6 over 2 is 3, take away 1 is 2. Right, we should be able to start plotting these points now. If we move this back down, And we start plotting the points. So the first point is 0, negative 1. So 0, negative 1 is there. 1, negative a half is going to be about there. 2, 0. And we've got 3 and half. You should be able to see these all going in a straight line. 4, 1. 5, 1 and a half. Just crossing that line there. And 6, 2. Like I say, we can see that these are all going in a straight line. So we just need to try and join them up with a straight line as well. Oh, excuse me. Try that again. Okay, again, due to the technology I'm using, that's not so easy to do, but there's a straight line that's approximately going through those points. Now, the next thing the question is asking us to do is find the estimate for the solutions of x plus 2y equals 8 and y equals x over 2 minus 1. Now what this means is, where are those two answers the same? It's effectively solving the equation simultaneously using the graph. Now, as we can see from my graph, we already have a point right here which is where the two lines cross. So where these two lines cross or intersect, that is going to be our solution. Now we can see that that goes on 5 on the x-axis, and it also goes at 1.5 on the y-axis. So that's going to be our answer. X equals 5, y equals 1.5. Okay, that could be 1.5, it could be 3 over 2, but 1.5 will do. Okay, now on to a bit of simplifying algebra. Quite nice questions here. First of all, just multiplying the two numbers together. 2 times 4 is going to be 8. B cubed times b squared is going to be b to the power of 5, because we add the indices when we multiply the base number. Okay, moving on to the second question, it's kind of the opposite. We're doing division. So first of all, 4 divided by 2, we just look at the numbers first of all, it's going to be 2. And then we have p squared divided by p. Well, there's kind of an invisible indice here, which we're going to just write in, p to the power of 1. Okay, so if p is the power of 1, and we have p squared divided by p to the power of 1, well, we just subtract 1 from 2, because we're doing the opposite to what we did before. So that's just going to be p, or p to the power of 1 again. Q to the power of 4 divided by q to the power of 6 will leave us with a negative, because 4 take away 6 is negative 2. So our answer is 2p q to the power of negative 2. There's our 4 marks. Alright, now we've got a standard form question, question 14. If we're doing distance is actually speed times time. If we use our little speed, distance, time triangle, speed, distance, time, distance equals speed times time. So what we need to do is multiply these two standard form numbers together. So we've got 6 times 10 to the 2 multiplied by, this is one whole number, multiplied by 8 times 10 to the 4. Okay, and that can be rearranged to being 6 times 8 times 10 squared times 10 to the 4. That's a lot easier to think of it like that. 6 times 8 is going to be 48. 10 squared times 10 to the 4 is 10 to the 6. Okay, but this isn't actually standard form. The question is asking us for a standard form answer, so we need to make the 48 10 times smaller, and to keep it balanced we need to make the 10 to the 6 10 times bigger. So 48 goes 10 times smaller, 10 to the 6 goes 10 times bigger. So we add 1 to the indice, and that's going to be our answer there. Right, now, solving simultaneous equations. We have two equations which will ultimately meet at one point, and therefore the x and y value will be the same at that one point. So we need to first of all adjust one of the equations so we can do some elimination. To be able to eliminate, we need the coefficients of either the x or the y to be the same number. Now, what we'll need to do here is return the top equation into an equation that starts with 6x, so the same on the left hand side. So we're just going to multiply by 2, multiply all the top by 2, and we've got 6x plus 4y equals 16. I'm just going to write out the second equation, 6x take away 5y equals 34. So when we say elimination, we're basically just going to eliminate the x's. We're going to take the bottom equation away from the top equation, and that's going to give us the following. 6x take away 6x is 0, 4 take away negative 5y. Let's just think about that. 4 take away negative 5, that becomes plus, so we've actually got 9. That's going to be 9y. I need to be careful with that sort of equation. Then we've got 16 take away 34, which is negative 18. Okay, now to solve to find y, we need to divide by 9. So 18 divided by 9 is 2, so negative 18 divided by 9 is negative 2. So that's one of the solutions. Now to finish this question off, we need to put that negative 2 into one of the original equations. So if we take the one of the smaller numbers, we're going to sub y equals negative 2 into 3x plus 2y equals 8. Right, so that will be 3x plus 2 times the bit we're substituting in, the negative 2, equals 8. Okay, that's 3x take away 4 equals 8. If we solve this equation now, add the 4 to both sides, we've got 3x equals 12, divide by 3, cancel the 3's out, divide by 3, x equals 4. Okay, so our solution is x equals 4, y equals negative 2. Of course we can write those answers in the right place, 4, negative 2. The next question is about making m the subject of the formula. These can vary in difficulty quite a lot, but we need to apply the same rules that we use when we're solving equations. We need to move things around by applying inverses. Now this question here, we want to get rid of the h and we want to get rid of the 6. We'll start off with the h because it's just been added on. When something's added on, it's nice and easy. We're just going to take it away. So take away h from both sides. Take away h from both sides. That's going to leave us with p take away h equals 6m. So in the same way as we'd solve an equation, we would take away a number from both sides. It's the same thing. Right, now we want to get m on its own, so we need to get rid of 6. Well, 6 is a number that's being multiplied by m, so we're going to divide by 6. It's the opposite. And we're going to divide by 6 on the other side. And that's the question finished, actually. That's all we have to do. Like I say, sometimes these questions can be a lot more complicated. Okay, so that's going to be m equals p take away h divided by 6. Okay, this question is about finding the mode. We're looking at cumulative frequency later on, but the mode is the group that's got the highest frequency. Now, if we think back to basic sets of data, the modal value or the mode value is the most common. This is the same thing. It's just got the highest frequency, the most common, which we're talking about. Wrong thing there. That group there has got the highest frequency, so the group is actually 20 and 30. Squeeze it on a little bit there. Okay. Next part of the question is completing the cumulative frequency table. Well, cumulative frequency is just basically the running total, and so we're just going to add up the values of the frequency in the previous tables as we go along. So the first one's just 16. That's nice and easy. The next one, we add on the next frequency, which is 26. So 16 plus 26 is 42. 42, then we're going to add on the 23 for the 30 to 40 group. 23 plus 42 is 65. And then we're going to add on the 10. 7, let's that one up. 75. And then the last one is adding on the final 5. Now the trick here is that this number at the bottom should be equal to the total. We just double check what was in the question. Yeah, there we go, we had 80 flights. So that's our check. Alright, that's our 1 mark. So we don't get a lot for that, but what we do get is the ability to do the cumulative frequency graph on the next page. So that's going to be a little bit tricky to see both of them, but we're going to start off with plotting these values here. We're going to plot the larger value of each group, alongside the community frequency. Community frequency will always go up the side. So the first point we're going to look at is 2016, then 3042, 4065, and so on and so forth. Okay, so using the community frequency table on the previous page, we need to start plotting the points, and we are going to zoom in to do this to make it as accurate as we can. The first one is at 2016, so along the corridor 20, up the stairs 16, going to be there. Okay, then we're going to zoom out and move across a little bit, zoom in a bit. And the next point is going to be 3042, so 30, oh, not high enough, 3042 is up here, 3042. Now we need to plot the next one, which is 4065, so we'll zoom out. Okay, and 4065 is going to be around about there, although it's slightly too high, but that's okay. We're going to then plot the last 2 points. We've got 5075, 5075, which is going to be slightly further up, which is going to be round about that point there. Okay, and then the last point is going to be 60, 80, so along the corridor 60, up the stairs 80, which will be this point here, and of course that should be the very top because it's the highest frequency. So if we just zoom out, that's one mark for getting those points there. Now we need to join these up with a smooth curve, not straight line. We start at 0, 0, and we're just going to go smooth curve through them like that. It's hard to get it exactly perfect, but that's quite nice. That'll do. It's a nice smooth curve. If we do straight lines, we will lose that mark. Okay, the next thing that the question is asking us to do on the previous page is to find out the median delay. So this is reading off this median and then or interquartile range of the delay. So if we just write in median, okay, and interquartile range. Well, the interquartile range is the upper quartile. Take away the lower quartile, so we have to work out both of those first. But just going back to the median, what we need to do is look at this community frequency diagram and think total number of people involved here is 80. So the middle person, the median, is going to be at 40. So we just need to draw a line across at 40, and we're going to have that across. Not the neatest line. I will stress you need to use a ruler to do this in the exam. Unfortunately, I can't do this in recording software, but the 40 should bring you down. On this diagram, it's going to work out coming down here about 28 or 29. Now, if you look at the solutions that's supplied with the actual exam paper, it does state it's 30, but the difference is the community frequency diagram is ever so slightly less accurate on one or the other, and both answers will be acceptable providing the answers are drawn in the same way as we've done here. So that's 28, and that's our median is 28. Okay, so next thing we need to do is look at the interquartile range. So the upper quartile is the halfway point between the top and the median, which is 60. So 60 across. Oh, put the pen on. 60 across, and then we need to take that down. Be as accurate as we can. Obviously with a ruler you'd be a lot more accurate with this, and that comes down to about 36. So that upper quartile is going to be 36 there, 36, and then you need to take away the lower quartile. With the lower quartile is 1/4 of the way up, which is halfway between 0 and the median. So we do the same thing. That's at 20, halfway between 0 and 40, and then when we hit the line we come down, and that gives us 21. So if we take away 21 from 36, we'll end up with 15. Now again, the actual solutions that come with the Pixl paper state 23 and 37. Now they're not significantly different. It will give an ever so slightly different interquartile range. It's actually 14 and we get 15, but because we've graphically shown how we've got these answers, this is absolutely fine, and a little margin of error is allowed as long as it's not absolutely terrible. Right, now we're into surds. Question 18, having a surds question, that's quite tricky, but it's not impossible. We need to expand these brackets in the same way as expand quadratics. So let's just write them out again. It's a bit bigger. 1 plus root 3. Right, and what we're going to do is we're going to do what I'd call the quadratics in the moon. We're going to multiply out each term. There's the first multiplication. So 2 times 1 is 2. I'm going to do 2 times root 3, which is 2 root 3, and that's a positive 2 root 3, so we put a plus. Then we have root 3 times 1, which is root 3, again it's positive. We're going to have root 3 times root 3. Well, when you have a root times a root, that becomes root 3 squared, and the square and a root cancel out, making it just 3. Okay, so we need to just simplify this up a little bit. 2 plus 3 is 5. Just looking at the first and last term, 2 root 3 and root 3 is just going to be 3 root 3. It's a bit like simplifying algebra. There's 2 lots of root 3 and there's 1 lot of root 3, which means there's 3 lots altogether. So this is in the form a plus b root 3, where a equals 5 and b equals 3. That's it. Okay, question 19. Here we have a question involving similar shapes. Now, when you have similar shapes, it means one shape has been enlarged. In this case, we have a shape that has a side 4 centimeters that has been enlarged to 6 centimeters. So, what do we multiply 4 by to get 6? The way we do that is we do 6 divided by 4. So the scale factor equals 6 divided by 4. This would equal 3 over 2. 3 over 2. Okay, so what we need to do now is find the surface area of the larger box. If the surface area of the smaller box is 50, we're going to multiply this by 3 over 2 squared, because we're not doing a length, we're doing the area. So we're going to square 3 over 2, and that's the same as 50 multiplied by 9 over 4. So if we multiply 50 by 9, we get 450. Then we divide that by 4 and we get 112.5 centimeters squared. Okay. So going backwards now, we've got a volume of the larger box being 50. If we're going from the larger to the smaller, we're not going to multiply by the scale factor, we're going to divide by that scale factor. But because it's volume, it'll be the scale factor cubed. Okay, so 50 divided by 27 over 8. This is the same as 50 multiplied by 8 over 27. This seems like quite a complicated question for a non-calculator paper, so it is possible that it's been made up with a question from a calculator paper. But 50 times 8 divided by 27 is actually equal to 14.81. Okay, so that would be the answer. Okay, question 20 is a tree diagram question. Now, a tree diagram question means we need to do lots of filling in of these gaps, and that shouldn't be too tricky because they are fairly straightforward in terms of what probabilities are provided. So we're going to look at the first game. If Vichy has a probability of winning of 0.5, that's 50%, or a probability of drawing 0.3%, then the probability of losing will be just those two numbers taken away from one whole, which is 0.2. Okay, so that's fairly straightforward for the first bit. Let's move over to the second game. There's nothing in the question to imply that the probabilities change from the first game to the second game, so now we're just going to focus on this one, and the probabilities will be the same. This one will be 0.5, the draw would be 0.3, and the lose would be 0.2. Now this is just the same, it's repeated down for each strand, so 0.5, 0.3, 0.2, and the last one 0.5, 0.3, 0.2. That is the 2 marks. That's quite nice, easy 2 marks there. Okay, the probability that Vichy will win both games, well, we have to think about what happens in the first game. The probability of Vichy winning in the first game is 0.5, as we see in the middle there, and the probability to win the second game is 0.5 as well. So we're going to write those two probabilities down, 0.5 and 0.5, and then to find the probability of one happening and then another, we are going to multiply those two numbers together. Okay, 0.5 times 0.5 is 0.25. Okay, and that's the other 2 marks. Okay, so here we have quite a tricky circle theorem question, and it's made it more tricky because we need to add in an extra line, and I'll explain why in a minute. We put a line between B and D. This means we can use one of the circle theorems, which is one of the lesser used circle theorems. Now the rule is the angle between a chord and a tangent is equal to the angle in the alternate segment. So which we mean is this one here. This is the between the chord and the tangent, and then the alternate segment will be this angle here. So basically those two angles are the same, so I'm just going to write that in as being 54 as well. 54. We do need to say the rule. We'll come to that in a second. Okay, so that's 54. We can also see that from these lines here, these are two equal length lines, which means it's an isosceles triangle, which means that this angle here is also 54, which means that this angle here would be 180, take away 108, which is 72. Okay, so that's part of the rule, but we are asked to find out the angle BCD. Well, the angle BCD is this angle here. Now you may have recognised already that we've got a bit of a quadrilateral going on. This is the quadrilateral here. Okay, so that is a cyclic quadrilateral, which means that opposite angles will add up to 180. So we now need to do 180 take away 72 equals 108. That's actually our answer, 108, but there's a lot of rules going on there. Okay, now it asks for a reason for each stage you're working. So first of all, we need to state that the angle segment theorem is being used. Now the angle segment theorem is the angle between chord and the tangent are equal to the angle in the alternate segment. Okay, so that's one rule that we've used. Once we got that, that gave us the 54, but we can also see there's another 54 because of the isosceles triangle, so we need to write that down as well. So there's an isosceles triangle, isosceles triangle, so two angles are equal. Okay, so that was another rule. Looking back, we've got two angles are equal, gives us the other 54. So then angles in a triangle add up to 180, so DAB is 72. So angles in a triangle sum to 180. And the other rule was the cyclic quadrilateral. Just look at that again, where we've got the blue line, the opposite angles in a cyclic quadrilateral sum to 180. So down here we'll do it again. Opposite angles in a cyclic quadrilateral sum to 180. So those are all the rules we need to use, and we've already got an answer up on the diagram here. This is our answer. Okay, so we need to make sure we highlight that as well. Okay. Okay, question 22 is about transformations of graphs. So we're going to be able to transform this graph with a variety of different ways, and when we transform it, the point A will move. Okay, so we're going to zoom in a little bit. First of all, we're going to look at y equals f of x minus 3 in brackets. Now when we have f of x minus 3, that means we are going to move the entire graph to the right 3 spaces. Okay, so we're going to move up here, and just to try that out, we're going to move this entire graph 3 spaces along. Okay, so that makes this coordinate down here 5, -4. Okay, we're going to rub that out and put the answers in. 5, -4 is the coordinates of that. Okay, and we'll put those in over here. 5, -4. Right, and next we're going to move over here, and we've got 5 taken away from y equals f of x. Okay, so y equals f of x, take away 5. That means the whole thing is going to be moved down 5 spaces. So like the last one, we moved it across 5 spaces. This one's going to be moved down, sorry, 3 spaces. This one's going to be moved down 5 spaces. So the point A is now going to go to 2, -9. It's going to go from -4 down 5 spaces to -9. 2, -9. Okay. Next one. Y equals negative f of x. Well, that means the whole of the graph, all the y coordinates are going to be multiplied by -1. So that actually will flip it upside down. Just to show you what that looks like, it's going to go up and then down like that. At this point here, it's just going to go up to the positive version. So 2, 4 will be its coordinates. 2, 4 as opposed to 2, -4. We just zoom in on there. And the answer is going to be 2, 4, as mentioned. 2, 4. Okay, so zooming back out of that and looking at the last question, we've got y equals f of 2x. So what that means, it's quite a tricky one, this one. It means all the x coordinates are going to be divided by 2, okay, or multiplied by a half. So if it was y equals f of 3x, it would be dividing the x coordinates by 3. Y equals f of 4x would be dividing them by 4, etc., etc. In this case, we're going to divide 2, the x coordinate, by 2, and it's going to give us 1. And then the y coordinate will just stay the same. Okay, so 1, -4. Okay, that question done. Okay, so a question about vectors. First part of this question is asking us to explain or state BC in terms of A and B. Well, BC is this bit here. Okay, so how can we go from there to there? Well, we can't use unknown, so we have to use the route that we do know. So we're going to go back down this route here. That's going to give us -6b. Then we're going to go back down this route here, which is going to be -6a. The negative just implies we're going backwards. And then we're going to go up from O to C, which would be 12b, positive, plus 12b. So to simplify that, that's just going to be 6b take away 6a. 6b take away 6a. That's that part done. And now this is we'll find out that vector questions always have a trickier section. So what we need to do is start looking at the diagram and putting in x as being the midpoint of CD. Well, x is already there, okay, and y is the point extended on BC, such that BC is to CY is 3 to 2. So if we draw that on BC to CY, and this is going to be on Y point here, and that means our ratio here is going to be 3 to 2. So 3 to 2, just for information purposes. Okay, and then the question is actually asking us prove that O, X and Y lie on the same straight line. Okay, this is a question that involves QWC, so we need to make sure that we are showing everything that we're thinking and make sure that we get the marks for those. Okay, so if we're proving it on the same straight line, then OX is going to be parallel to OY. It's the same straight line, so they go in the same direction, so they're parallel. Okay, so if we just mark those on first of all, we're going to have OX and we're going to have OY. So we're just looking to find out what both of those are. Now, OX is just going to be 12b, take away 3a. Okay, so we're going to write that down. OX is 12b take away 3a. So OY is the next one to work out. Let's just have a little look at that. Okay, so to go from O to Y, we're going to go from O to C first of all, but then we are going to add on 2/3 of the BC distance, or 2/3 of BC is 2/3 times 6b take away 6a from question A. Okay, so it's going to be 12b to start with, and then we're going to add on 2/3 of 6b take away 6a. So we have to tidy that question up a little bit. 12b stays the same at the moment. 2/3 of 6b is going to be 4b. 2/3 of 6a, or negative 6a, is going to be negative 4a. So that should equal 16b take away 4a. To see if these lines are actually parallel, we need to factorise them both. So we're going to factorise 12b minus 3a, and that's going to equal 3 open bracket 4b minus a. And we're going to do the same down here, but we're going to have 4 open bracket 4b minus a, and you can see they both have common factors with a scalar outside. So underneath we're just going to write down they have common factors multiplied by different scalars. Multiplied by different scalars. By scalars we mean a number on its own, a 3 and a 4. Okay, that's questions done. Okay. Algebraic fractions. Okay, well, algebraic fractions are not too tricky at GCSE level. What you do need to appreciate is that there are common factors on the top and the bottom. Now if we were to write this out, we're going to have x plus 10 times x plus 10 times x plus 10 5 times, and the same 4 times on the bottom, which means that the x plus 10 would cancel out 4 times, and actually what we can do is we can cancel out these indices. So that means all of that's gone, and we're just left with x plus 10 to the 1. So x plus 10, we could put to the power of 1, but we don't need to. Okay, this one's a little bit more tricky because we need to factorise both of the expressions. So the top is actually trickier than it looks. It's going to be a difference of 2 squares because x squared is a square term and 25 is a square term. So when we do difference of 2 squares, it's x plus 5, x take away 5. And on the bottom we're going to have a quadratic factorised, and we're going to have x and then 5 and 2, just to double check that. X times x is x squared, 2 times 5 is 10, 2 times x is 2x, 5 times x is 5x, and they would add together to make 7x. Now the trick here is that we need to cancel the common factors. Well, the common factors are x plus 5. So our solution is going to be x take away 5 over x plus 2. And that's the end of the non-calculator Pixl paper for higher Edexcel. Hope you found it useful. Good luck in the exam.